Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone. Welcome to lecture 29, Organic Chemistry 1. Today we will start on chapter 8, Structure, Synthesis and Reaction of Alkene. Alkenes are hydrocarbons with carbon-carbon double bonds. Alkenes are sometimes called olefins. Alkenes are among the most important industrial compounds, and many alkenes are found in plants and animals. As an example, ethylene is a growth hormone used to ripen fruits. It's also the monomeric unit for making polyethylene, and a variety of other industrial and consumer chemicals. Bynene is another example, is a major component of terbentene, the paint solvent. Alpha-farnesene, found in nature, its waxy coating on apple skins. And there are many alkenes in nature and industrial forms. We will start with nomenclature. Nomenclature of alkenes. The following rules summarize the IUPAC system for naming alkenes. Number 1. Select the longest chain or largest ring that contain the largest possible number of double bonds. Once again, select the longest chain or largest ring that contain the largest possible number of double bonds and name it with "ene" suffix. If there are 2 double bonds, the suffix will be diene, 3 will be triene, 4 will be tetraene, and so on. Number 2. Number the chain from the end closest to the double bond. The end to the double bond, not to the substituent. Okay? Number a ring so that the double bond is between number 1 and 2. That's in case of cyclic. Okay? Place the number giving the location of the double bond in front of the root. That was that old system before 1993. In front of the suffix "ene" or "diene", this is a new system. What do you mean by that? Okay. Now, let's see IUPAC. This compound called ethene. This compound propene. This is 1, 2, 3, 4, 5 carbons. That's benzene. In the old system, we put 1 because it's 1, 2, 3, 4, 5. And the shortest would be number 1 to get to the double bond. The old way was 1 benzene. The new IUPAC way is bent 1 ene. Bent 1 ene. For this compound, that's 1, 2, 3. So you have at 2 position 2-methyl propene. Common name isobutylene. Here you have 2 double bonds, so you have to take both of them, and then you can number. That's 1, 2, 3, 4. So on 2 you have methyl. That's 2-methyl buta 1,3-diene. When you use diene, triene, keep the A in the name. Buta. Okay, in here you have ethynyl benzene or styrene, ethynyl benzene or styrene as a common name. Number 3, name substituent groups as in alkanes, indicating their location by the number of the main chain carbon to which they are attached. The ethynyl group or propynyl group are usually called vinyl, acceptable in IUPAC, and for the propynyl, allyl group is acceptable too. For compounds that show geometrical isomerism, add the appropriate prefix cis trans when applicable, or E or Z. Cycloalkene are assumed to be cis, otherwise stated, unless named otherwise. Okay? If you are going to use cis trans, you have to have two identical groups on each carbon of the double bond. Okay? If not, you have to use E and Z. For the priority, we have taken that before, but I'm just summarized, go over it quickly. For the priority, atoms with higher atomic number receive higher priorities. So iodine will be higher than bromine, than chlorine, than sulfur, than fluorine, than oxygen, etc. Isotopes, the higher carbon 13 will be higher than carbon 12. Tritium would be higher than deuterium, than hydrogen. In case of tie, you start with here with CH2, and here is CH2. You look for the next, okay, next group will be CH2. Okay, we have here CH3, but CH2 Br. So Br will be much more senior, so the whole group will be senior. CH2Br senior than CHCl2, higher than C, carrying CH3, 3 of CH3, and this is higher than CH3, CH2Br. Okay, how we got here hydrogen, and here is hydrogen, here's Br, and here Cl senior. Here is carbon, 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 carbon. Here is carbon chlor senior. Here is carbon, carbon, carbon. Here is carbon, carbon, hydrogen. This is senior. One extra carbon. Here is carbon, double bond carbon, means carbon twice with carbon. So this carbon connected twice to carbon. Okay, and this carbon twice to carbon. So it's this one with this one, and we add 1, 2. Carbon triple bond carbon. This carbon connected 3 times to carbon. Okay, 1 carbon, 2 carbon, 3 carbons. And this carbon again, it has to be 3 carbons. Okay, 1 in here, 1 in here, and 1 in here. Okay. Carbon double bond nitrogen. Mean the carbon coupled twice to nitrogen. Okay, this carbon twice to nitrogen. And then nitrogen twice to carbon. Okay, this is 1 and this is 1. This carbon connected 3 bond to oxygen. Okay, 1, 2, 3. And this oxygen twice to carbon. Okay, this oxygen twice, one in here and one in here. Okay. The following names are incorrect. The roller structure is represented by the incorrect name, or constituent structure if the name is ambiguous, and give your drawing the correct name. Cis 2,3-dimethylbenzene. According to the name, we can draw this structure. It's 1, 2, 3, 4, 5. So it is 2-benzene, okay, 2-benzene, 2,3, 2,3, dimethyl, benzene. Looking for the carbon number 2. Here we have two methyl group, identical. If the carbon carries two identical group, we cannot name it cis or trans. Here we have two same group. So when we say cis, that's wrong. Okay? And the correct name will be 2,3-dimethylbenzene, 2-benzene. Or you can write 2,3-dimethylbenzene, 2-ene. Okay? 3-vinyl hexfluorine. To draw this compound, we will start with hex 4-ene. Hex 1, 2, 3, 4, 5, 6. On 4, we have double bond. On carbon 3, we have vinyl. On carbon 3, we have vinyl. So we can draw this one or this structure. Let's assume that we have this one and we have to write the correct name. The correct name, we have to select the longest double bond with the highest number of double bond. So the vinyl group should be part of the main chain. The problem did not specify the geometry, whether it is cis or trans, so we assume this one, we can just work it out. For the first double bond, this one, we cannot say cis or trans, because this carbon carries identical group, H and H. So they are the same. We can say that this double bond carbon could be cis or trans. Forget about it. Okay. Now 1, 2, 3, 4. On number 4, we have this group H and H. Two identical groups, opposite to one another. So it's trans. So we can say that this is trans. Number system 1, 2, 3, 4, 5. So we have on carbon 3 we have ethyl hexa 1,4-diene. So the name of the structure we draw here, trans 3-ethyl hexa 1,4-diene. If you would like to say E or Z, we come to this. On this carbon, which group is senior? This part, this group, or H? Oh, this group, of course, carbon. So this is number 1. and here this is number 1. The 2 senior on this carbon double bond carbon are in different direction. So I can, instead of say trans, I can say E. Okay? 3-ethyl hexa 1,4-diene. 2-methyl cyclopentene. So we draw the cyclopentene, saying 2. So we number system 1, 2, 3, 4, 5, and on number 2 write the methyl. That's according to the name given, right? But when we look, the right way to number the carbon carrying the branch should be number 1. So it's 1-methyl cyclopentene. 6-chlorocyclohexadiene. Hexadiene. Double bond, double bond. 6, 1, 2, 3, 4, 5, 6. But the right way is the shortest number system, shortest to the location of the substituent. So it should be 1, 2, 3, 4, 5, 6, and the right name will be 5-chlorocyclohexa 1,3-diene. Again, in the problem, they did not locate the diene. Where is diene? We have to really give the number for 1,3-diene. 2,5-dimethyl cyclohexene. Cyclohexene, 1, 2, 3, 4, 5, 6. It's telling us on 2 have a methyl, on 5 you have a methyl. Of course, this is not the right way to number the ring. The double bond should be 1, 2, shortest number to the substituent. So it will be 1, 4 rather than 2, 5 dimethyl cyclohexene. Cis 2, 5 dibromo 3-ethyl bent-2-ene. We can draw it this way. Okay? Do this carbon or that carbon carry the same group? Here is Br, here is CH3, here is ethyl, here is bromo ethyl. There is no two identical group on this carbon and that carbon. So we cannot use cis designation for naming. We cannot apply it. Okay? So we have to go with E and Z. This carbon carries Br and methyl. Which one is senior? Br. Carbon number 3 carry ethyl, CH2 identical with CH2. Here is CH3 and here is CH2Br. So this group will be senior. So the senior here and the senior on that carbon are on opposite direction. that is E. So it's E. 1, 2, 3, 4, 5. So it's 2 and 5 dibromo. On carbon number 3 we have ethyl bent to ene. So the name is E25 dibromo 3 ethyl bent to ene. Give the systematic IUPAC name for the following. Okay, long chain containing double bond. Name the shortest two double bond, not to the substituent. 5, so it will be bent 1 ene. On carbon number 4 we have a branch here, methyl, so it's 4 methyl bent 1 ene. What about this compound? Okay, now we have to select the long chain containing double bond. So it will be 1, 2, 3, 4, 5, 6. On number 2 we have ethyl. So 2 ethyl hex 1 ene. Number the large chain containing double bond. Containing double bond. This structure 1, 2, 3, 4, 5. So it will be 2 and 5 dimethyl cyclopenta 1 and 3 diene. For this structure, cyclohex 1 ene. So 1, 2, 3, 4. On number 4, we can call this vinyl group or ethynyl group. Okay? Vinyl group or ethynyl group. So it's 4 ethynyl cyclo 1 ene or 4 vinyl cyclohex 1 ene. We can name this compound as benzene derivative. So this group will be allyl group, allyl benzene, or we can consider it as prop 1 ene, 1, 2, 3, and phenyl group is a branch, so it is 3 phenyl prop 1 ene. For this compound is 7-member ring with 3 double bond, so it's hepta 1, 2, 3, 4, 5, 6, 7. So it is 1, 3, 5 triene, and on 7 you have methylene CH2 double bond, so it is 7 methylene cyclohepta 1, 3, 5 triene. Okay, let us solve this question. Determine which compound shows cis-trans isomerism. Draw, label the isomers using both cis-trans and EZ. Nomenclature where applicable. 1 bentene or bent 1 ene. When we draw this molecule, we find that carbon number 1 has 2 identical hydrogen atoms. So we cannot say that there is geometrical isomers. Okay? Bent 2 ene. When we draw the structure, we can see that we have 2 geometrical isomers. one with two hydrogen trans to one another, trans, and another isomer where they are in a cis position. So this is trans and this is cis. If you would like to name it via E and Z, we look for carbon number 2 carrying hydrogen and CH3. Which one is senior? CH3. Carbon number 3 carries hydrogen and ethyl group. Which one is senior? Ethyl group. So the ethyl group in here and the methyl group on that carbon are in different position. So they are E configuration. In the other one, they are ethyl and methyl on the same direction, so Z configuration. We have two isomers for that. For 1,1-dibromopropane, carbon number 1 carries two identical atoms, bromine atoms. So there is no geometrical isomer. For 1,2-dibromopropane, carbon number 1 and 2, if the bromine on the same direction, then it is cis. Opposite direction, it's trans. If you look for carbon number 1, Br is senior. Carbon number 2, Br is senior on the same direction, Z. In this one, Br and Br are opposite direction, it's E. For 1-bromo, 1-chloro, hexa, 1,3-diene, we can draw 4 different isomers. 1E, 3E, 1Z, 3E, 1E, 3Z, 1Z, 3Z. If you look for the carbon number 1, it carries Cl and Br and hydrogen, and then C double bond C ethyl group. Carbon 1 and 2 carry 4 different groups, so we cannot give carbon 1 to cis or trans, but we can give E and Z. For example, if here Br and Cl on carbon 1,1, Br is senior. On carbon number 2, we have hydrogen and we have carbon double bond carbon, CH2, CH3, and again, this group will be senior. The two seniors are on different positions. They are E. Looking for carbon 3 and 4, we have this group senior over the hydrogen, and this one senior over the hydrogen. Again, they are on opposite position, so we have 3E. Coming to this one, carbon number 1, this is senior. Carbon number 2, this is senior. Of course, over the hydrogen in here. They are on the same side, so Z, 1Z. Okay? So we can build up 1, 2, 3, 4 isomers. We cannot name or give cis or trans for carbon 1. Okay? We don't have 2 identical groups on 1 and 2. See you in the coming lecture.